Good day! So sa video na to, we'll take a look at some examples ng integrals na mag-yield sa atin ng inverse trigonometric functions. So you could look at it as a special case ng trig sub. Except that, dediretso na natin gagamitin yung theorems na nakita natin dito sa previous video na ito. So I would like to invite you first to pause this video and try to answer these 3 problems on your own. Then mag-compare tayo ng results pagkatapos. Okay? So welcome back and let's start. So start tayo dito, integral of sine x over the square root of 3 minus cosine squared x. We will use u substitution para ma-simplify natin expression. We'll just let u be equal to cosine x and du, syempre negative sine x dx. Performing this substitution, we could rewrite our given as, labas ko na yung negative, so yung negative dito, siya yung negative na to, yung numerator na sine x dx, that will be equivalent to du, and yung denominator natin will be square root of 3 minus u squared. And notice that this is exactly yung form, no, na diniscuss natin sa previous video, na ibibigay sa atin yung inverse sine of u over 3. Ano ulit yung form? Yung ginamit nating theorem dito ay the integral of 1 over square root of a squared minus u squared equal siya sa arcsine ni u over a. So a is equal to square root of 3. So diretso na tayo dito. Hindi na natin gagawin yung trig sub kasi ginawa na natin siya nung pinrove natin yung theorem. And then we'll just back substitute si u pabalik kay cosine x. So this is equal to arcsine of cosine x over square root of 3 plus c. Rationalizing na lang dito for the final answer. Okay? So let's move on to the next item. We want to find here the integral naman, the definite integral from 0 to 1 of 1 over e raised to x plus e raised to negative x. So baka hindi obvious, no, na andun siya sa form na gagamitin lang natin yung theorems natin. So we'll need to do a bit of manipulation. We will multiply e raised to x over e raised to x. So yung purpose nito is yung e raised to negative x, ma-reduce natin siya to a constant. So this will be equal to the integral from 0 to 1 of e raised to x na yung numerator natin, and yung denominator natin will be e raised to 2x or e raised to x quantity squared plus 1. So andun yung u squared plus a squared natin na form. We'll again use u substitution but we'll let u be equal to e raised to x. So yung purpose natin ng pag-substitution dito ay para ma-transform siya dun sa form na gagamitin lang natin yung theorems natin on integrals that will yield inverse circular or inverse trigonometric functions. But take note that this is a definite integral. So dapat yung limits of integration natin, idadamay natin dun sa substitution na step. So if x is equal to 0, ang u natin ay e raised to 0, which is equal to 1. If x is equal to 1, ang u natin ay e raised to 1, which is just equal to e. Again, e is Euler's constant, 2.71828 something. Okay. So, performing the substitution, our integral, note mo natin limits, is now from 1 to e instead of 0 to 1 ni du over u squared plus 1. And we know that this will be equal to 1 over 1 times arctangent of u over 1, which will evaluate from 1 to e. San galing yan? Ginamit natin yung result ng theorem natin sa previous video na ang du over u squared plus a squared, yung integral nun, ay equal sa 1 over a arctangent of u over a plus our constant of integration. So we'll just need to evaluate using the second fundamental theorem of calculus na this is equal to arctangent of e minus arctangent of 1. Actually, okay na to siguro na final answer. But we have a value rin kasi for the arctangent of 1. It's pi over 4. So, evaluate na rin natin siya. So, final answer is arctangent of e minus pi over 4. And then, let's move on to our final example. Here, we want to find the integral of 2 over the quantity t minus 3 times square root of t squared minus 60 plus 5. Yung t minus 3 dito, medyo giveaway na, no? Kung ano yung kailangan nating gawin sa kanya. So, we'll complete the square dun sa expression na nasa loob ng square root. So, si t squared minus 60 plus 5, that is equivalent to t squared minus 60 plus 9 para makomplete yung square, then minus 4 para ma-retain natin yung value niya. So we'll rewrite this as 2 over t minus 3 times the square root of the quantity t minus 3 squared minus 4. Then yung integral nun. So we could still take this u substitution step na u is equal to t minus 3, du equals dt para masulat natin siya in that form. Labas na natin yung 2. So du over u times u squared minus 4. We know that this is equal to 2 times 1 over the square root of 4. Kasi 4 is 2 squared. So 1 over 2. Arc secant of u over 2 plus our constant of integration. So bakit natin to alam? Kasi nga, ginamit natin yung theorem na the integral of du over u times square root of u squared minus a, this is equal to 1 over a times arc secant of u over a plus our constant of integration. So all that remains is to back substitute. Magka-cancel yung 2 tsaka yung 1/2. So we'll get arc secant of t minus 3 over 2 plus our constant of integration. And that is our final answer for this problem. So to summarize, yung theorems natin, nakuha din natin siya by using trigonometric substitution. And then once we had those three theorems, pag lumabas na yung forms nila, we could just apply the theorem without using trig substitution anymore. But the thing is, if you forget naman yung mga forms, you could always go back to trig sub at makukuha pa rin natin yung same results. So I hope naging pareho tayo ng mga results dahil tinry nyo muna siya bago nyo pinanood yung video. At salamat ulit sa pakikinig.